Hello, everybody. Today we are working on Chapter 7, Lesson 1, and we're digging into Lesson 3 as well. I know, 2 lessons in the same day, but we've got this. First thing we need to do is please put your name on the top. My name's Miss Moradic. Please put your actual name. And then when this is due, and then the hour that you have science. So, what we're looking to do is we want to be able to summarize the cycling of Earth's materials through plate tectonics, and therefore how are conditions on Earth changing over time. Now, with this unit, we do want to get kind of the basic information, and then we've got a number of different kind of hands-on activities where you're going to be using some colors, some cutting and pasting, but we want to have the most basic ideas to get us started. You're going to notice that this note sheet looks a little bit different. It's actually used for something different most years, and a big shout out to Mrs. T for making this. We are using this because it's got us the most basic information for our unit, and we want to have this as a really, really, really good reference to go back to. So, without much further ado, let's get started. We've got this unit on, looking at the cycling of Earth's materials and how our conditions changing. We've already learned about the rock cycle. Now we're going to keep going, and it's on continental drift hypothesis, which is lesson 1. And then we're going to get into chapter 7, lesson 3, which is the theory of plate tectonics. Now, when you're looking, chapter 7, lesson 1 is just all on one page. And chapter 7, lesson 3, there are pictures, and it's about 1.5 page. So that's why we can definitely get that done for today. We're getting those big, big, big basic ideas because we'll have so many things we're doing kind of hands-on already. So first thing, you will notice if you go to this on Google Classroom, have the digital copy, that it is colored. And these colors are going to match up with our textbook. You might be looking, you're like, wait, red, isn't that what the big heading is? It is. Yellow, isn't that what our vocab is? It is. So if you wanted to open up the digital copy, you're going to want a paper copy of these. And even if you don't have a printer, rewrite them or put them on blank paper so that you have them as a paper copy. So getting started, log on to your online textbook. We're now going to be in the Earth and Space textbook. You don't need to do anything. This is something that your science teacher has taken care of behind the scenes, so to speak. You just need to log on to the online textbook to get started. So click into this, and our first one is we're going to chapter 7, lesson 1. So to get there, it's just like it's been all year. The textbook works the exact same. It just has different content. We'll go up to the upper left hand here, and we're looking at chapter 7, lesson 1, the continental drift hypothesis. Personally, I'm going to turn off the audio icons. You can leave them on if you want. And then I'm going to zoom in here just a little bit. So remember I said that these notes the colors match up? Well, there's the red Pangea, red here. You'll also notice that these are still in an outline form where it's like the big topic is all the way to the left and then they get indented in. That's on purpose. This is what a good notes would look like if you were writing them completely on your own. You'd want to indent things in and use the right colors, use the colors that are going to match up. So our big red one, Pangea. So who is the scientist that proposed the idea of continental drift? So here we go, Pangea. Did you know that Earth's surface is on the move? Can you feel it? Each year, North America moves a few centimeters farther away from Europe and closer to Asia. That is several centimeters, or about the thickness of this book, or a textbook in general, that would be. Even though you don't necessarily feel this motion, Earth's surface moves slowly every single day. Now, this is kind of an interesting fact to think about. We're moving away from Europe about the width of a textbook every year. You're probably like, that's nothing, Miss Moradic, especially when you're thinking in the vast area of an entire ocean, like the entire Atlantic Ocean. And yeah, a few centimeters is basically nothing. Even if you put 2 or 3 textbooks together, that's still not much. But now let's think about, you guys are 13 and 14 years old. That's 13, 14 textbooks of distance that it's moved. That's starting to get quite a bit. I mean, we're getting into a few feet it's moved, but still a few feet in the spans of many, many, many miles, thousands, hundreds of miles, ocean wide, still isn't that big a deal. So let's think about Miss Moradic. I'm 28 this year. That's getting to be a much larger area. We're starting to get a lot farther away. Now, let's think about if we're thinking in thousands of years. That's getting to be a lot of textbooks, and now we're starting to get to miles. If we think about the idea and the theory, which a theory, it has a lot of evidence to support it, we're going to talk a little bit about evolution later this year. And that theory says that things have been moving for like millions of years. Now think of how far that textbook width is over that many years, right? So, sorry, a little side there. Nearly 100 years ago, Alfred Wegener, a German scientist, began an important investigation that continues today. Wegener wanted to know whether Earth's continents were fixed in their positions. He proposed that all the continents were once part of a supercontinent called Pangaea. Over time, Pangaea began breaking apart, and the continents slowly moved to their present positions. Wegener proposed the hypothesis of continental drift, which suggested that continents are in constant motion on the surface of the Earth. So, who was that scientist that proposed the idea of continental drift? It is Alfred Wegener. Make sure you've got the correct spelling here. It's going to count. Alfred Wegener. Well, actually, it's a W. You just say it with a V. It's a German name. Wegener. He noticed that the continents look together like they fit like a what? We're going to get to that here in a minute, and we'll answer these last two. These notes that we're looking at today is trying to get us into taking notes like how you take them by hand instead of having it literally word for word from the textbook. But it's still pretty close to word for word from the textbook. It's all right there. You'll just have to read a tiny bit. I know, crazy, but you can handle it. So Alfred Wegener observed the similarities of continental coastlines now separated by oceans. Look at the outlines of Africa and South America. Notice how they could almost fit together like pieces of a puzzle. Hundreds of years ago, mapmakers noticed this jigsaw puzzle pattern as they also made the first maps of the continents. So if I come back here, Alfred Wegener and other map makers noticed that the continents looked like they fit together like a puzzle. He proposed all the continents were once connected. There's one, Pangaea, that was the supercontinent. See, it's in yellow. And if you go to the notes, it's yellow here. So we're going to make sure we spell that correctly. So Pangaea. Blank was the hypothesis that suggested continents are in constant motion. Continental drift, the hypothesis of continental drift. And if it brings you joy and happiness, if you want to go through, I know I've got a few people out there who would like to do this. In your notes, if you wanted to change these to have the same colors that are on the page here, by all means, go for it. I can make them red. I'm going to need some blue. I'm going to need some yellow. But if you wanted to make it so your notes are also colorful, just like the page, by all means, go for it. Okay? So you're going to keep going. We're going to keep going for chapter 7, lesson 1. When you finish the page 1, we're heading to chapter 7, lesson 3. Now to get there, exact same thing, go up to the top here. Chapter 7, we're just going to click on 3. Now we are going to learn about lesson 2, but we have some different activities we're going to use for that instead. So if I flip, so if you notice, chapter 7, lesson 1 just takes the first page together. We almost have most of it done. So here, the theory of plate tectonics, chapter 7, lesson 3. So the plate tectonics theory, you'll notice it's red. If you look over here, it's red. The first one's going to be yellow. Oh my goodness, it all's just working out here. So when you blow into a balloon, the balloon expands and its surface area also increases. Similarly, if oceanic crust continues to form at mid-ocean ridges and is never destroyed, Earth's surface area should increase. However, this is not the case. The older crust must be destroyed somewhere, but where? By the late 1960s, a more complete theory called plate tectonics was proposed. The theory of plate tectonics states that Earth's surface is made of rigid slabs of rock or plates that move with respect to other. This new theory suggested that Earth's surface is divided into large plates of rigid rock. Each plate moves over Earth's hot and semi-plastic mantle. So, plate tectonic theory, blank, our Earth's surface is made of rigid slabs that move. We need to write in plate tectonics. And are you using correct spelling? Yes, you are. Okay. So then you see there's a blue here. Oh, I wonder, will it match up? Oh, it's like there's a blue right there. Okay, I'm being slightly sassy. I'm being slightly sarcastic, but that's what you're doing, going through here. Feel free to refer back or change the colors so that they do match up the same. And then the very last thing, just with any of our notes that we have our wrap-up form. So you'll head over here, Chapter 7, Lesson 1 and Lesson 3, add your name, your science class, and then adding in what are the answers here as you go. As always, please let your science teacher know if you have any questions. As always, a paper copy here is going to be your best copy to have, but please let your teacher know if you have any questions. Otherwise, do have a good day. Bye, guys.